Greetings. This is an introductory video on how to use Stata. For most of you, if not all of you, you've never used this software, and so I'll be going over some basic concepts to help get you started. Once we get going, the majority of what we'll talk about here is covering what's in the introductory PDF that I provided. So I actually just downloaded the new version of Stata, Stata 17, and it comes evidently in dark mode because this is a new look. Or maybe it sensed that I use dark mode on my computer and automatically adjusted. I'm not sure. So I guess the first thing I'll show you how to do is how to change the colors of Stata. If you right click anywhere in the window, you can select Preferences. As you can see, the Windows tab is already selected here. And in that Windows tab, you can select a color scheme. So it looks like mine came with dark automatically. The standard is a white background and black text. Now I'll move this aside so you can see this. I don't like this very much. My eyes have a lot of trouble reading that. The contrast is way too high. So what I typically do is I opt for the classic Stata colors, which is what I was used to from a long time ago. And I like these because it is a dark background and there's a lot of color to help separate different text. So as you can see, there are results that we'll be getting when we run statistical tests or when we estimate a regression. There's the standard text, green. As you can see here, it's just, well, standard text. If we make an error, which you will, it'll be in red. That makes sense. I like that. The input that we write is in white, and if there's ever a link, it's in this cyan color. And as you can see, there's links here. If I click this, we'll go to stata.com, and if I click this help Unicode advice, it's actually going to open a help file. Maybe we'll do that to demonstrate how that works. And the background is black. Now, if there's anything you don't like here, you can make your own custom colors, and you can choose what colors you want everything to be. But in any case, I actually prefer the classic, so let's go with that. I hope it's okay with you as well. All right, now let's go ahead and take a look at some of those links. As you can see here, this is a help file. It's saying Unicode is now supported in Stata. That's something new from the old version I just upgraded from. So if I click that, you'll see a help file opens up here. And this is a movable window, unless you're in full screen mode, and then it would be a tab. So evidently this is saying that Stata is now Unicode UTF-8 aware, so you can use these accented vowels, you can use symbols. In other languages, this is konnichiwa in Japanese. Okay, that's great. But as you can see, you can click links, and they will be, if you're using Classic, in cyan, that's that light blue, and it'll open up a help window for you that you could search for other help topics as well. We'll probably come back to that later in the video. Just to make things easier to see, I'm going to go ahead and maximize this. I'm on a Mac, so I can enter full screen. There we go. And just like most programs, if you want, you can adjust the size of the different windows. So down here is the command window. As you see, when I click it, there's going to be a cursor blinking. So this is where we can type commands. Over here will be the variables once we have data. And down in the bottom right are some properties of the data set that, as of right now, does not exist. Now, something new I've noticed in this data is we have a history tab, which will list all the commands you type. So if you want to type it again, you could just click it up here instead of retyping it. And some project manager tab. I got to be honest, that's new. I'm not sure what that is yet, but we won't need to be using it in this class anyway. Now, these used to be separate. It used to be that this history window was over here on the left. Now, when you first download Stata, it asks you if you want that view, and I clearly said no, because we can always just toggle between the two, and I like having more space to view here in the middle. Okay, I'm actually going to push that command down because this command window does not need to be so big. The results window, I think, is better to be big. And let me try one more customization, actually, that I usually do when we're in person. I'm going to go back to Preferences, actually, and I'm going to change the size of this text to 14 to make it hopefully easier for you to see on this video. Okay, so what I'm going to do now is cover the topics that are on the introductory PDF. And the first thing I ask you to do is load some data that I've already made for you called revenues.dta. So I've already converted this to a Stata data set ending in .dta. And what you're going to want to do is click File, Open, and then find where it is on your computer. So I just found where it was on my computer and opened the data by pointing and clicking to it. And notice that when I did that, Stata filled in here a command that I could have typed instead. Also, you might notice that the variables have been filled out here. We have 4 variables in this data set. And if we click on the History tab, it gives us the history of what we typed. So if I expand this here, you see it keeps the command. Although I pointed to File and clicked Open and then chose the data set, Stata basically wrote the command for me. And so if I wanted to rerun that command, I could just click there. You see now it's copied down in the command window, and then I hit Enter. Now, of course, we already have the data set open, so nothing changed here. But you can see the command history window records that I've now typed that twice. So I'm going to go ahead and close that, go back to the variables. Now you may be wondering, well, where is the data? So it's loaded in Stata, where can I see it? Well, let me teach you your first command. In the command line, if you type the word browse, it will open a browser window. So this looks like a spreadsheet, maybe, somewhat like Excel. And here in this dark mode, maybe it looks a little different because it's a black background. If you use a light background, you will be able to see the cells and it'll look more like Excel. But as you can see, it shows our data, and I've got for you revenue here in millions of dollars. I've got the variable for year. I've got team names of Major League Baseball teams. And then I've got another team variable here that is an abbreviation. And you can see that these are all in different colors. We've got yellow, blue, and white. Now this is actually new to me because those colors used to be black, red, and blue in the old version of Stata. But again, I literally just downloaded this, so I guess we're learning together. Now, what is the meaning of these different colors? Do you notice anything similar about the white variables? They're numeric. The string variables, which are made up of characters, are in yellow. And we have this other variable team that also is made up of characters. However, it is not in yellow. And if you notice here, if I click on team name Arizona, Diamondbacks, in the first row, that value will appear much like it does in Excel. Likewise, if I click on year, 1998 will appear. If I click on a different year, that different value will appear here. However, if I click on team, ARI for Arizona, we see the number 1. If I click on ATL, we see the number 2 appears. Now, the reason why this variable is the color cyan is because we're actually looking at the variable labels, or the value labels, I should say, of this variable. This variable is actually coded as a number, 1, 2, 3, 4, 5, all the way up to 32 for every MLB team. But rather than show you numbers, it shows you a label. So in this variable is an encoded a rule that says whenever you see the number 1, show the user the characters ARI, which we will read as a shorthand for Arizona. Whenever you see the number 2, show the user ATL, which we will recognize as an abbreviation of Atlanta. So this is very useful because using the colors, we can quickly identify the different types of variables that we're looking at. Now also notice that rather than open up a different window, when I've maximized data, it opens up another tab, so I can easily just click between our standard view and the browser window. Now if we only wanted to see some of these variables, suppose I didn't want to see team name, I can click here and get rid of that. I can toggle it on and off as I like. We can even rearrange these. Maybe I think year should be first, so I drag it up here and switch it with revenue. We can change the order here manually. Now, as you can see at the bottom, we have 450 observations. It's not uncommon in some of my research to have millions of observations. And sometimes you want to take a look at the data, as we are here, but only a subset. You don't want to be overwhelmed with a data set that's so big you can't read everything. So suppose we only wanted to look at the Los Angeles Dodgers. What I could do is come back to my command line here and I'll type browse if. So we can make these conditional statements. I want to browse the data, but only if, let's say the team name. So instead of typing it, I can come over here and click this down arrow. It'll fill in the name for me, you see down here. Browse if team name equals, and I have to hit equals twice. To say something is exactly equal to a value in Stata, you have to use equals twice. If you use the equal sign just once, you're assigning a value to the variable. But when you say equals twice, you're saying this equals a value right now. So I'm going to use double equals, browse if team name, double equals, and then in quotes, I'm going to write Los Angeles Dodgers. Now I have to put it in quotes to tell Stata that this is a string. We're not typing in variables here or numbers. You can see as soon as I close those quotes, it changes colors. Now I don't see anything because I misspelled Dodgers. Stata's not like Google. It doesn't guess what you want, and it doesn't spy on you, as far as I know. So let's go back and say, oh great, now I gotta type this long line again. Or wait a minute, I don't, because I can go to my history, click the line I just typed, and go ahead and fill in that D that I missed for Los Angeles Dodgers. That saves me a lot of time. And as you can see, now we're looking at the data set consisting of only the Los Angeles Dodgers. Now maybe we only want to look at a particular season. Maybe we want to look at all teams in 2010. How would I do that? See if you can come up with the answer before I show you. But you only have a moment because I'm going to type it. And to save time, I'm going to click my conditional browse statement, but rather than team name, I'm going to replace that with year. What if we want to say browse if year equals 2010? And here I can just type the numbers because it's not a string variable. And what we are looking at here is all the revenues in millions of dollars for every team in MLB in 2010. Now I've shown you how we can toggle on and off variables here. We could have also done that by typing in the command line. We can say what variables we want to browse. I could say browse team and revenue only. Maybe that's all I care about if year is 2010. And in that case, it'll toggle off the other variables for me. And so this is useful when you're looking at large data sets with hundreds of variables and you only want to look at a subset. You can tell Stata, just show you the ones you care about. And sometimes it's easier to do that than toggling off, literally 100 variables that you don't want to look at after opening the browser window. Now there's another way we can get information on what type of variables we're looking at other than colors. So if I go back to my command line, we can use the command describe, and it will describe our data set. Or if we give it a particular variable, it'll describe just a variable. So first I'm just going to type the word describe. This is a command. And as you can see, it describes the data set that we have in memory. It tells us where the data came from, how many observations there are, how many variables there are, the date it was created. And then if you look at the table, it gives us the variable names, the storage type, which is what type of variable it is, the display format, the value label, and only one variable has that, and we talked about what that was, and the variable label. So in Excel, if you open this data set, all you will see are these variables, and you won't have colors to tell you if they're characters or numbers or what type of data storage is being used. In this view, we can tell. So for example, revenue in year is a float variable that is a numerical variable. So floats are real numbers with about 8 digits of accuracy, so to the 8th decimal place. Long variables are integer values between somewhere around negative 2.1 million to positive 2.1 million, so any integer in that range. Our team variable is long because we want it to be an integer because we have 32, and we want it to just take integer values between 1 and 32. Team name, as you can see, is a string variable because it consists of characters. And you can see it's listed as str29 because there are 29 characters maximum. So that means the longest string in this variable could be 29 characters long. Why do we have different types of storage? Well, it may not be as important now as it used to be. Well, I guess it depends on the size of your data set, but different types of storage takes up different amounts of memory. And so if you have ginormous data sets or not a lot of memory available, or if you have the memory but your computer slows down when you're processing, say, data sets that are unnecessarily large, you might want to store the data in a smaller format. So for example, we might want to use the team variable, which is a number for each team, rather than 29 character long string. As you can imagine, storing the information Los Angeles Dodgers, that phrase, takes up more memory than a simple number that is only one digit. or it might be 2 here, depending on what the value is for the Dodgers. But in any case, storing a 1 to 2 digit number takes up a lot less space than an entire phrase of 29 characters or less. So that's the reason for the different variable types. We may want to get rid of the team name completely and just use the team variable. Now here we have a small data set, so it's not that big of a deal. Now we could also tell Stata that we only want to describe a particular variable. So we can say describe, say, team. Say that was the one we were interested in because we didn't know why it was showing us blue letters, but in the browse window, we recognized it was actually a number. And actually, before we do that, let me show you something. Rather than type describe, I can type as little as the letter D, and Stata still knows what I meant to say. Now, how did I know I could do that? Well, experience, but also by reading the help file. So any command that you learn in this class has with it an associated help file that you definitely should read. The way to do that is to type help and then whatever the command is. So here I'm going to type help describe. As you can see, it opens up the help window. Let me actually increase the font here so it's easier to read again. Put it to 14. There we go. And in the help files, it'll describe how you can use each command. So here, it says we can use describe, and then in brackets, optionally, you can give it a variable list. So instead of describing the whole data set, you could just describe a handful of variables or just one. And then there's a comma if you want, it's optional in brackets. And there's memory options. So all options come after a comma for commands. And then the memory options are listed down here. If we use the simple option, it displays only variable names. Short displays only general information, evidently doesn't give us everything, and so on and so forth. So you can read here about all the different ways you can use describe. And typically when you scroll down, there is an example like you can see here. So they'll give you examples with system data to show you how it works. So let's say you never used describe before. Let's say I didn't give you a data set. You could come down to this example, copy and paste each one of these command lines and see how it works. Now this is introducing something else in Stata. You see the command here, sysuse. Stata comes with it a lot of example data sets that they will reference often in the help files. And the purpose of these data sets is for you to have examples to use the commands on and follow along with the help files. So if I were to copy that and paste it into the command window, you can see it loads a new data set. It loads an automobile data set, and after the comma is the option clear saying, go ahead and get rid of the data that's already in memory, the baseball data, we don't care that it's not saved, get rid of it, and load this 1978 automobile data. Now going back to the help file, after we load that, it suggests to type describe. This way, we can see how the variable works. So if we type describe, once again, it describes the data set for us. And here we're looking at the make, price, miles per gallon, and other specs of cars from 1978. So whenever you learn a new command here, I strongly suggest reading the entire help file. It's very illuminating. It'll answer most questions that you might have for me upon learning the command. And the last thing I want to point out was a trick I learned from reading these help files that I actually just used. So if I scroll back up to the top, you will notice when we're reading the syntax of describe, the letter D is underlined. So when you're reading a help file on a command, they will have underlined either the first letter or maybe the first couple letters. And whatever is underlined is the smallest amount of letters that you can type, and Stata will perform that command. So obviously there are other commands that start with D, but since describe is the one that uses D as a shortcut, the other commands will be comprised of other letters. And you'll notice a lot of the options also have short versions. So simple, you can write as little as SI, and Stata still knows what you're talking about. So let's try that out actually. What if I wanted to describe this automobile dataset and use the simple option? I could type as little as D, and then comma for the options, SI instead of simple, and it gives me this simple, well, it looks like just list of variables really. So that's how you know the shortcuts for all the commands and options A lot of people, when they get into coding and writing syntax, really love writing as little as possible, being as efficient as possible. And so if you're one of those types, now you know how to do it. But let's get back to our baseball data set. What I'm going to do is go back to my review window, click the use command that loaded it so that I don't have to find it again, and we're back to where we started. And if I want to check without opening a browser because I'm lazy, I can actually type the command list, and it gives me the whole data set in the command window. Now, you don't want to do this for larger data sets because it'll obviously be very messy and take up more than the screen. But here we have the small data set, so I can actually use the command list, and it shows me everything right here. And the whole point was just to check that I had the baseball data set back. Okay, another basic command that you should know right off the bat is summarize. It's something you should do whenever you have new data. So summarize, as the name implies, summarizes the data set. It gives you the number of observations, the mean value, the standard deviation, and the min and maximum value that the variables take. Now you'll notice team name doesn't give us any information, and that's because it's not a numerical variable. So summarize is only giving us really a summary of numerical variables. If we want, we can summarize only one variable, because sometimes we have thousands or hundreds of variables. So maybe I just want to summarize year, and for short, we'll just get that back. Summarize also has a detailed option. So I could say summarize year detail after the comma if you want to get more detailed information. So when you do this, it'll also give you the percentiles. It'll give you the 1 percentile, 5 percentile, the median, or 50th percentile, right? It gives you the largest 4 observations and the smallest 4 observations. It gives you the standard deviation again, but also the variance, skewness, and kurtosis if you're into those higher level measurements. Now you will use this a lot because sometimes you'll be wanting to look for outliers, or you'll want to see how rare high or low values are, and this can give you a really quick view. So for example, we probably want to look at something a little more interesting than the year. Probably want to summarize something like revenue. We want to talk about how much money is being made in baseball. So when we summarize revenue in detail, we can see for this time frame that revenues go as high as 471 million, as low as 46.5 million. That's a huge difference, right? We see the mean and median are almost the same, 156 million, and the standard deviation is 60 million. Now, what if we want to know how many big earning teams there are? Let's look at the ones that earn at least 400 million. I could use an if statement here as well. I could say summarize revenue if revenue is greater than 400. So I can write conditional statements like this, and now this will give me a summary of all those big earning teams. We can do it in detail if we like. And so we can look at the variation here just amongst the top earning team years, because these are going to be the same teams in every year. Now, if we wanted to know what exact teams are we talking about here, we could use another conditional statement that we've already learned. Instead of summarize, we can browse. What if I typed browse revenue if revenue is greater than 400? Well, we would want to get rid of the detail option. Browse doesn't have that, but if we type browse revenue, if it's greater than 400, well, then we see there's only 4 observations. And actually, we want to know who they are, so I could type or here just toggle myself the team name. Yep, these are all the Yankees, and these are the last 4 years. So we know how to summarize numerical variables. We know how to look at all variables. We know how to filter our views. Let's go back to that string variable team. When I summarize the variables, and you can see I can type as little as sum here. Actually, I think I can type just SU, but I like to type sum. We didn't get a lot of information from team name because it's a string variable. For that, we would want to use tabulate. So if I use tabulate, I type in team name. If I tabulate team name, what I will get is a list of every value the team name takes, the frequency, how many times we see that value, what percent of the data set takes that value, and then we get a cumulative percent. Now, this is a very important thing to do because you would expect to have the same number of observations for each team. You would expect 15 each. But looking at this, you'll notice we have a problem. There's one team with 7 observations and one team with 8. So here we have 7 Montreal Expos, which is a now defunct team that moved to Washington, and 8 Washington Nationals. So those who know their baseball history know the reason why this is because the Expos moved to Washington. So you've got to make a choice. Are we going to treat this as the same team or not? In research that I've done, I went ahead and treated this as the same team because they literally moved the team and manager and everything to Washington. It was a different location, but the same team. Just a different name, a different branding, but it was a continuation of the Montreal Expos, basically. So if you decide to do that, when you see this tabulation, you would want to rename Montreal to Washington and just treat them all as the same. That way you have the same number of observations per team. Now let's try to do this for the other team variable. What happens if I tabulate team? So this works as well. It works well because these are integers. We might have a problem, however, if we didn't describe the data or if we didn't know that these are labels we're looking at. Now let's see what would happen, because this is a common error, if you were to look at this data and say, now I want to look at the Dodgers. Let's browse if team equals LAD. That's the Los Angeles Dodgers. Well, if I type that, let's see what happens. Browse if team double equals, and then in quotations, I'm going to write LAD because it's a character. And there we get the red color finally. Type mismatch, we get an error. And we get a link. So something's gone wrong. It says type mismatch. That means there's a mismatch in the variable type. We're treating this variable like it's a string, when in fact it is numerical. So Stata says, hey, wait a minute, you're telling me to look for character values in this variable. This variable is not a string. You're doing something wrong. Now you should pay attention to these errors. Students often ask me why their code's not working, but they don't read the errors. Stata will tell you what you've done wrong. And if you're confused, you can click this link, which is an error code, and it will try to describe, not always in a way that you can understand, but it will attempt to describe what's gone wrong here. So here it says, look, you have a type mismatch. In an expression, you attempted to combine a string and numeric subexpression in a logically impossible way. For instance, you attempted to subtract a string from a number, or you attempted to take the substring of a number. That might sound really confusing to you, but you will still get the idea that there's something wrong with me treating a numerical variable as a string or vice versa. So something you can do, if you want to know how to refer to the Dodgers, and suppose we didn't have the string variable, you'll need to refer to them by the number. But how do you know what number means LAD? What you can do is tabulate the team and use the option no label. And now we have numbers. Well, now the difficult thing here is, well, which one was the Dodgers? I'll have to scroll up and say, okay, the Dodgers were, let's see, 1, 2, 3, 4 up from the 7, or where the cumulative percent was 46.67. I can scroll down here, find that 46.67, and say, okay, they're team number 14. Not the most convenient way to do this. And when you have a lot more values, when we're looking at something bigger than just MLB, this can become infeasible. So a trick you might want to do for this type of variable is add the number label to the team label. So here I'm going to write num label, it is a command, team underscore LBL for team label, comma add. So what that just did is it adds the number that we're looking at here, the actual value, to the label of the values in the variable team label. Now where did I get this expression? That's not the command is num label. If I describe team, you'll see that it has a value label, and that value label is called team underscore LBL for team label. That is the set of rules in the background. We don't see it, but it's the set of rules saying when you see number 14, display the characters LAD. So that contains those rules. So what we said here is, I want you to take that set of rules and add the actual number to the label, right? So now when I tabulate team, it gives me the numbers next to the label. So if I want to refer to the team with the abbreviation LAD, I know to type the number 14. So this is a very useful trick that I didn't know for many years. And so I want to make sure you know it right away when you're at the stage of just exploring your data. It makes things very easy. Now, at some point, you're going to be doing analysis on this data. And often, we want to run some kind of command separately for different values of a variable. For example, we might want to calculate the average revenue per year, or we might want to calculate the change in revenue per team across year. There's all sorts of things we might want to do. Now, one way to do that, you already know. Let's first tabulate the year to see all the values it takes. Okay, 98 to 2012. We could say summarize, I could type sum for short, summarize revenue if year equals 1998. And we can get the average revenue here. And then I could do the same thing, type it or click command, and just change this to 1999. Well, now this is going to get kind of tiresome doing this from 98 to 2012. I don't want to type over and over. And in fact, whenever you find yourself doing a repetitive task with any kind of coding software, there is a way to automate that process. And it's probably worth your time to figure out how to automate it instead of doing any repetitive task on your own. After all, that's the whole point of automation. That's the whole point of computers, right? To be more efficient than we as humans can be. So we can tell Stata to run a command such as summarize revenue for every value of year. We can just tell it that all at once. But first we need to make sure the data is sorted. Stata wants it in order. So this is similar to sorting data in Excel. Here we would just type sort, and then if I say year, this is the same thing as if you were using Excel and you said sort by the variable year. Now if we look at our data, let's go ahead back to the browser. Oh, we want to look at everything. Just type browse again. Actually, you can type as little as BR, but I like to type bro because it's funny to say, let's browse the data. In any case, here we're browsing the data, and you can see it is sorted by year. If I scroll up, because it looks like 2007 was what I was looking at there, yes, indeed, the top is 1998, the bottom should be the last year, and it will all be in order. Now, it's somewhat random what it sorts on outside of year, right? This is not in alphabetical order, this is not in numerical order, and the revenue is not in order. If you wanted, we could sort by more than one variable, similar to what you do in Excel. So I could have said sort year revenue. Maybe I wanted to be sorted by year and then by who made the most revenue. And if I browse now, we see that it's sorted by year indeed. And then within year, it's sorted by revenue, starting at the lowest and counting up. Okay, so now our data is sorted. What we can do is tell Stata, I'm going to run a command. I want you to summarize revenue. I'm going to type summarize revenue again, but I want to do this by year separately. So what I do at the beginning of the command is I write by year and then a colon. And Stata will do whatever command you write after the colon for each value of the variable year. So I hit enter and it does it instantly. And you can scroll through here and see how the mean revenue increases over year. And now here when I go up, I'm going back in time, so it's decreasing. But you can see it went ahead and ran that for each year, and it didn't even take a second to do that. Now think how long that would take you to type by hand versus that single by year command. Now this is the old way to do it. You do have to sort your data because look, if I try to do, let's say I wanted to say summarize year for some reason, but by team, right? So what if I said by team, or like by team summarize revenue? I guess that would make more sense. That's something we would actually want to do. Not sorted. It doesn't like that. It wants you to sort by team. Now, rather than say sort team and then by team summarize revenue, Stata has a, I guess, relatively new command. Well, maybe it's old now, but you can just type this all in one by saying by sort. That command will sort the data for you. So we can say by sort team, summarize revenue. And now it summarizes the revenue across years for each team. And again, it did it for 31 teams, even though Montreal and Washington's the same team. I guess it's debatable, but we have 31 values of team. And it just did that in less than half a second. This is powerful stuff. And this isn't even the beginning. So this is all very basic summary things you can do with data sets. Once you open them, you can browse them. You want to summarize their values. Make sure it makes sense. Make sure there's nothing wrong, no outliers, no errors. And when I say make sure, I guess my tone right now is implying typically there's not. In reality, every data set I've ever received or done work on has errors, issues, typos, or things about it that make analysis complex or difficult, or sometimes impossible, that you wouldn't think existed until you went searching for problems. Now, maybe typically in life you don't want to go searching for problems. Let me tell you, in research, with data, you want to go searching for problems early and often because you want to know now something weird about the data. For example, we have a team that changed location and name, Montreal to Washington. I want to know that now before I spend hundreds of hours coding analysis, assuming I have 15 observations for each team when in fact I don't. I want to know that in the beginning. And so do you. It'll save you a lot of time. So this is part of the data cleaning process. You always want to spend a lot of time doing this. People typically, when you get a data set, you want to jump in, start estimating regressions, start making graphs and figures. Just look at the data. Spend a good half day doing nothing but summarizing data, looking at data, making sure it makes sense, making sure it's what you expected. So take some time to look at this data set, explore it, see if you find any other issues, anything else that's interesting. Read up on some of the help files, and in the next video, I will show you how to combine data sets. Almost certainly in your research project, you will have multiple data sets, maybe player revenues, player stats, team revenues, that you'll want to combine into one big data set to run your analysis. So next video, I'll show you how to do that, how to make sure they combine in the way you thought they should, and then how to generate new variables and new calculations based on the information contained in the raw data.